This video is about vectors and scalars. A scalar quantity is one that does not have a direction associated with it, and a vector quantity does have a direction associated with it. That's the main difference between the two. In chemistry class, I would say that most often you're going to encounter just scalar quantities. Examples of that would be things like mass measured in grams, or temperature in degrees Celsius or Kelvin, time measured in seconds, or energy in joules or calories. All of those quantities don't have a direction associated with them. It wouldn't make any sense to say the temperature outside today is 22 degrees Celsius north. It doesn't make any sense because temperature is a scalar quantity. There is no direction associated with it. Vector quantities are different. Vector quantities are directional quantities, and we have lots of them in physics. We're going to encounter lots of them as we go along in physics. Examples include things like displacement, velocity, acceleration, force, momentum, torque, electric field, magnetic field, and many more, as it turns out. All of these quantities have a direction associated with them. For example, I could give you a velocity and say, oh, that person is going 60 miles per hour east. And that can make sense. And so velocity is a quantity that we call a vector quantity. They have magnitude and direction. How do we denote vectors? How do we describe vectors on our papers? Well, you can do it graphically by drawing arrows. The longer the arrow is, the larger the magnitude or the size of the vector. And the direction the arrow points tells you in what direction the vector points. So I could use this arrow to represent 5 kilometers per hour, maybe east, and a shorter arrow to represent 1.2 kilometers per hour east. Or maybe this arrow pointed towards the top, maybe that's 3 kilometers per hour north. When we write vectors in equations, we need to denote that that quantity is a vector. So we use the symbol for that quantity in the equation, like v for velocity, and we put a little arrow above it. Or F for force, we put an arrow above it. It's really kind of a half arrow, isn't it? You just draw kind of one end of the arrow there, one end of the tip, I should say. So E for electric field and an arrow above it, and P for momentum and an arrow above that. Physics, like many other scientific fields, has its own set of specialized terms and vocabulary. Like specialized terms that exist in medicine for certain diseases, or in keeping score in tennis, for example, have special terms for the score. In physics, we have special meanings for words, just like we do in any other field. And we actually make a distinction between the words distance and displacement. Those are two different things to a physicist. Distance is a scalar and displacement is a vector. So we might define distance as how far an object moves altogether, regardless of its direction. And we could define displacement, which is a vector quantity, as the net change in position from beginning to end, including the direction. If I rolled my chair across the board there and back, I might have moved a distance of about 2 meters. 1 meter there and 1 meter back. But my displacement would be 0, because I ended up in the same position that I started in. And so that's the difference between distance and displacement to a physicist. Distance is a scalar, displacement is a vector. And one more example, another set of physics terms, is the difference between speed and velocity. Now I know that when I talk with people on the street, or if I'm sitting next to somebody in a car, they ask, how fast am I going? I don't make a distinction between those two words, speed and velocity. But to a physicist, there is a distinction. And again, it's the distinction between a vector and a scalar. Speed is used by physicists, and it means scalar. That's how fast. What's the rate of change of position without regard to direction? But velocity is a vector. It's the rate of change of position, including the direction. So how fast and in what direction? So I might say I'm going down the highway at 65 miles per hour. If I say that's a speed. If I say 65 miles per hour west, that tells me the velocity.